In this question, we need to figure out the probability that a person has the antibody, and the letter that we used for this event was D from the previous part. Given that, so we know that, given that or knowing that the test shows positive. So the probability that we need to figure out is probability that the person has the disease now that we know that the test shows positive. Now if you look at the first part, we know that the probability of positive given that the person has the disease is 0.9985. But notice here we need to figure out the probability that someone has the disease given that the test shows positive. So here we'd have to use the rule, a form of the multiplication rule, and that is probability of disease and positive divided by probability of the test showing positive. So this is basically derived from the multiplication rule. Now all we have to do is write it in a way that we can plug in the numbers that we have so far and figure out the required probability. So in the numerator, again we use the multiplication rule, probability of the first event D times the probability of the second event positive given that the first event happened, or knowing that the first event happened, the whole divided by probability of positive that we know from the previous part, and it's equal to 0.015925. We've already calculated this, and the problem has given us these two probabilities. Now all we have to do is plug the numbers in. So when we plug in the numbers, this is what we get, and this gives us about 0.627. That's about 63%. So if someone tests positive and you know that they tested positive, what is the probability that they actually have the disease? That would be 63%. So there is still a 37% chance that the person who has tested positive will not have the disease. So probability that someone does not have the disease, knowing that they tested positive, is equal to 1 minus the probability that they have the disease knowing that they tested positive. So that would be 1 minus 0.627, and that is approximately equal to 37%. Now quickly summarizing what we did so far. First, we figured out the probability that a test shows positive, and that's equal to probability that they have the disease and show positive. So probability of disease times probability of positive given disease, or, so that's the addition rule, probability of no disease and probability of positive given that they do not have the disease. So that was our first step. Our second step was finding the probability that someone has the disease given that they show positive. And we first used the formula, which is derived from the multiplication rule, and that is probability that someone has the disease and shows positive over probability that someone shows positive. So when we expand this, this is the same as probability that someone has the disease and shows positive divided by probability that someone has the disease times probability of positive given that they have the disease plus probability that someone does not have the disease times probability of positive given that someone does not have the disease. So that is equal to probability. Now we're simplifying the numerator, probability of disease times probability of positive given disease divided by probability of disease times probability of positive given disease plus the probability of no disease times probability of positive given no disease. So what we have here, this is the Bayes theorem. So probability of disease given positive is equal to the right hand side. So this is called the Bayes theorem, but we did it in two steps, so we didn't have to apply the rule directly. We did it more by applying the rule, the multiplication rule in two parts, and basically we ended up using the Bayes theorem.